Hi everyone, and thanks for great introduction, Sri Lakshmi. My name is Nishan, and today we'll talk about building a React Native like runtime. First question: what is a React Native like runtime? So, what is this talk about? Something that allows you to write JavaScript to build a native app. And what is a native app? So, as you can see, there's iOS and Android. And for iOS, you have to write Swift, Objective-C, and then there are platform APIs. So iOS has UI kit, Swift UI, and Android has Android SDK. So you typically use these APIs to write a native application. So yeah, now the question is, can we use JavaScript to interact with these APIs and build a native app? Now, what is the point? Each platform has platform APIs, and you can use that to build a native app. So, yeah, what's the point? So, because how JavaScript works, let's try to understand that. There's a simple JavaScript program like Hello World that. So, we'll try to run JavaScript on native app. Okay, but first let's talk about Hermes. So, this is JavaScript engine developed by Hermes team at Meta. Here we are creating a native iOS application using Xcode. Okay, so now it's building and yeah. So we'll add some background color to our view to check if it's working. Okay, so we have our native iOS app right now running, and we'll install some Hermes engine dependencies. Yeah, so this is some C++ dependencies that is required by Hermes. In iOS, we can use Swift or Objective-C to write the native application, and from Objective-C, we can use C++ code. So Hermes is in C++, so and we installed its dependencies, so now we can start using Hermes in our Objective-C code. So just initializing JavaScript engine, and after that, we are injecting some script in it. So it's just like assigning a variable 1 plus 2, and after that, we are calling evaluate JavaScript method, so that will run our JavaScript. I was happy. I was very happy after getting this working. Like it took 2 days, and after that, I tried to add console.log to log my 1 plus 2 addition. After that, I thought how browsers do this, because console.log is the first thing that we use in a browser. So how browser adds console.log in a JavaScript runtime. So console.log is not part of ECMAScript. It's not built into JavaScript engine. It's something that platform adds on top of JavaScript engine. So we'll see how browsers add this. So browser has something called web API, where you have console.log, set timeout, document.create element, and we can use this in our JavaScript code, and that's somehow binded to JavaScript runtime. So that's how we are able to use these APIs in our JavaScript code in browser. This demo number 2, we'll try to add console.log into our native JS runtime. Okay, so we want to run this script, console.log hello React Nexus, but right now it crashes, so we'll add some binding code so that it runs. In the first line, we are creating a console object on C++ side using something called JSI. We'll see what is JSI in next slides, but it's basically creating a object on C++ side, and then we are setting a property called log on it. So here it's doing nslog. Nslog is an Objective-C API to log into, so it will, if we use this, it will log into Xcode's terminal. And after that, we are setting the global property on our JavaScript runtime, the console property. And now let's try running this. Okay, so here we have Hello React Nexus on data side. It's working. Let's try to print our original 1 plus 2 here. Okay. Okay, so there we have console.log working in our JS runtime on native iOS. Okay, so we are using something called JSI to create this console object on native side and binding it to our JavaScript runtime. So what is JSI? So JSI is called JavaScript interface. It's abstraction on top of JS engine APIs to talk to the JavaScript runtime. And it provides the ability to extend the runtime and add some platform-specific APIs to it. So the spec was created by React team at Meta. Uh, and there are different bindings available. So there's V8 JSI, JSC JSI, and here we are using Hermes JSI bindings to extend the Hermes JavaScript runtime. So, okay, so we got console.log working. Okay, so first, what is a document object in a browser? So if you open Chrome's console and write document in it and hover over it, it will highlight the entire page. So document object represents the entire web page. So let's try to associate some mapping of DOM-like APIs and native-side iOS APIs. So what we can do is when we do document.createElement, we can create a native view on iOS, and when we do append child, we can add we can append view on a root view controller on iOS. So most of the native platforms has like tree-like hierarchy of laying out views. So that's why we can associate some mapping. So yeah, let's try to add document.createElement in our JS runtime. So we'll try to run this code on our native app. Okay, so first we need to, again, our runtime doesn't know a document object. So we need to teach it that there's a document object and how to create native views. So first we are adding this global property of document in our Hermes runtime. And we are using something called host object for this. So we'll talk about that in the next slide. And also I've added some like really great resources by the end of the slide, so you can learn more about this later. So here we are creating the document object and attaching some properties like create element, append child to it, and everything is in C++. So this host object is like a glue code that we are using to call Swift APIs. So the actual code of appending child and creating element is written in Swift, but host object is used like a proxy object to do that. So here we have added some DOM-like APIs like setting color, font size, etc. And then we are setting, then now we will try to run this document.createElement append child JavaScript code. Okay. Okay, so if you see this code, it looks kind of similar to how we create views in DOM. It's creating a div, and after that it's appending, and then setting background color to black, and setting height and width. So ideally, if this works, we'll see a black rectangle on iOS screen. Okay, so yeah, this works, and we are able to create native view using JavaScript DOM-like APIs. Let's add some more properties. Okay, so yeah, we have Hello React Nexus here, and it's a fully native view. So you can as I said, host object, it's sort of like, so this document host object is like a C++ object. So when you write document.createElement, it goes through this document host object, and then create element, it eventually calls iOS side APIs. Okay, so we can also check the view hierarchy on native side. So if we there's in Xcode, there are some like great debugging tools. So you can check the native view hierarchy. So there's like 2 UI views and there's UI label. So we are using like JavaScript DOM-like APIs to create native views here. Okay, so we can add more APIs like on-clive, removing div. So for this, I'm actually will try to run the Xcode. and hopefully it works. This is not recording. Okay, yeah, it works. So we are running this code snippet. We are creating a button, appending, setting height width, and then we have also attached on-click listener on it. So when we click, it attaches, and click back, it removes. Yeah, it's a very ugly looking demo. Sorry. Okay. So yeah, so now we talked about iOS. Now what about Android? uh, I haven't prepared Android demo, but in Android you can do similar things. There's something called JNI. You need that to talk to C++ code. So you will create that. You will create JNI bindings, and then you can talk to JavaScript runtime and again extend the JavaScript runtime to use Android platform APIs. Okay, so there are current solutions like React Native, Native Script. They both use similar approach to talk and extend the JavaScript runtime. However, Capacitor uses WebView and message passing to communicate with the native APIs. So this is how Capacitor, and also there's a desktop UI library called Tori. It uses similar approach. So it uses WebView and and message passing is like it's like window.post message, how we talk to iframe. It's something like that, but it uses that to talk to platform APIs. Okay, so we created our toy React Native like runtime, but React Native does like a lot of things. We have just like added some APIs, but React Native is doing a lot. So if you can see at the bottom, this is the code that is written by us. It goes to something called React Native renderer, and that runs on JS thread. And after that, after that it calls directly to UI manager. It's a C++ code that is somehow binded to our JavaScript runtime. And after that, UI manager is responsible for creating something called shadow nodes that handles layouting. That happens on a layout thread. And after that, UI manager is also responsible for coordinating to mounting manager. And then eventually everything gets mounted on the native side. So everything is batched, super optimized, and everything. So here it's using 3 threads. So also like you can see some multiprocessing. So it's very optimized. And if you see React Native source code, it's like most of it is in Java, C++. Just not very accurate because there are also a lot of tests in C++, but still this gives you the bigger picture of what goes into building a React Native like runtime. And while on this stuff, this is like very lower level. This stuff is, I think, not needed for becoming a great React Native developer. But if you like to learn something under the hood, then yeah, it's useful. But now you know very core part of how something like React Native communicates with the platform. And this also applies in other JS runtimes like browser, Node.js, and Bun. They use different approaches, not JSI, but the gist is same. So yeah, thank you. All of this is possible due to numerous innovations and open source. And so I would recommend, if you want to learn more about JSI, you can check out this really great YouTube playlist by Oscar. And also Mark, he has great libraries built on top of JSI. So you can check its source code. And also you can look into React Native source code. So yeah, if you have some questions or want to talk about anything, you can connect on Twitter, and this is my GitHub ID. Yeah.